Okay, so let's do an example. So it says let S be the triangle with vertices at P0, 1, 2, 0, P1 equals 0, 6, 5, P2 equals 7, 2, 9. So this would be a triangle in 3 space. I've drawn it here in 2 dimensions, but it's actually in 3 space, this triangle. And it wants us to evaluate the surface integral over our vector field, where the vector field is 1, I, yj, 2x minus z in the k direction. So to do this, we're going to transform our triangle into a right triangle. So we're going to find a mapping that does that. So it's going to be an affine transformation. So let me write it down here. So our affine transformation would look like this. So I have to find conditions on the A1, B1, C1, and so forth. So let's make it so, say 0, 0, R of 0, 0 goes to P0, so 1 here. R of 0, 0 to be mapped to P0. R of, say, 1, 0 to be mapped to P1. And R of 0, 1 is mapped out to P2. So let's find conditions on the A's, B's, and C's to make this work. Okay, so let me erase a few things here. Okay, so we have this. So looking at the first one then, we're going to put 0 for U, 0 for V everywhere up here. So we can say then, so putting 0 for U and V up here, you'll just have C1 in the first component. And 0 for U's and V here, so you'll have C2. And 0 for U's and V's, you'll have C3 here. And this has to equal 1, 2. So then that tells us that C1 is 1, C2 is 2, and C3 is 0. So now we can replace those up here. So in place of C1 now I can put a 1. In place of C2 I can put a 2. In place of C3 I'll put a 0. Okay, now let's move on to next one. So this one I'm going to put 1 in place of U, so that's my U. That's my V. So 1 in place of U up here, 0 in place of V up here also. So doing that, we'll get this. So again, we're putting 1 in place of U, 0 in place of V, all across here, we'll get this. So then solving this, A1 plus 1 is 0. It means that A1 has to be negative 1. And A2 plus 2 is 6. So it means that A2 would have to be 4. And A3 would have to equal 5. Okay, so we can replace those then up here. So this guy will become minus. A2 is 4, so I can put a 4 here. And A3 is 5, so we can put a 5 here. Okay, and lastly, we're going to do the R01, so it'll be 0 in place of U, 1 in place of V up here. So doing that, we'll get this. So we'll have then B1 plus 1 is 7. That means that B1 will have to be 6, so then B1 is 6. We'll have B2 plus 2 is 2. That means B2 would have to be 0. And B3 would have to be 9. Okay, so we've found our mapping then. So my B1 is 6. My B2 is 0. And my B3 is 9. Okay, let's keep going. Okay, I'm going to erase this right here now. Okay, so now I'm going to find partial derivative with respect to u of my r function. So looking at this guy here, derivative with respect to u for the first component here would be -1, so it would be -1, say I. Then over here, derivative with respect to u on the second component would be 4, so it would be, say, 4j. Oops. And then last one, derivative of this guy with respect to u would be 5, so it would be 5k. And let's do derivative with respect to v also. So this guy, first component with respect to v would be 6, so it would be 6i. Second component with respect to v would be 0, so it would be 0j. And third component here with respect to v would be 9, so it would be 9k. Okay, so now we're going to do the cross product of these two things. So let's look at RU cross RV. So here's my definition of cross product. Put I, j, and k on top, then put your vectors in the second and third rows. So let's do the I component first. So to find the I, you take away the column it's in and the row it's in. So you'll have that 2 by 2 on there. So it'd be 4, 5, 0, 9, I. Then for J1, take away that and that 2, so it'd be minus -1, 6, 5, 9, J, and the K1 plus -1, 4, 6, 0, K. Okay, and let's work these out. So it'll be 4 times 9, so it'll be 36. Then -0, so -0 there. I, then minus 1 times 9 would be -9. This times that minus, so minus 30. J, this times that would be 0. Minus that. So we get then 36I plus 2 minus would be 39. J minus 24k. So recall this is our f that we're integrating over. So we're looking for the flux. This is the integral representation for flux. So we've shown in 15.6 that we derived this formula for the flux. So we're going to plug into that. Now here's my f up here. So going back up to my r function up here, let me denote the x, y's, and z's. So the x is the -u plus 6v plus 1. The y is the 4u plus 2, and the z is this guy over here. So let's look at this guy now. So it's going to equal then integral over d. We'll come back to that in a second. So f of, so it'll be f of r here. So pretty much in place of x, I'm going to put the -u plus 6v plus 1. In place of y, I'm going to put this and z plus this. So it's going to be I plus y, but y now is this guy up here. So it'll be 4u plus 2j plus 2x. So it'll be 2 times x now is this guy here, times -u plus 6v plus 1 minus z. So it'll be 5u plus 9v. This is k. And we're dotting that with our RU cross RV. So this is what we're called, this is our normal vector right here. Okay, so, and we found it up here, it'll be 36 I plus 39j minus 24k, then times our dA. Okay, so let's simplify this a bit. Okay, so doing this dot product would be 36. Then it'll be 39 times this guy. Then it'll be minus 24 times. Now let's simplify this inside. It'll be minus 2u minus 5u, so it'll be minus 7u. That'll be 2 times, that'll be 12v minus 9v, so it'll be plus 3v. And then it'll be plus 2. We're doing this, dA. Okay, so let me erase some things and keep going with this. So let me just mention here, so if you simplify this inside part here, you check, you can pause the video, work it out, you should get 324u minus 72v plus 66. Okay, now I'm going to erase some things. So just to summarize, so our flux we've shown is equal to the double integral over our D region, and our D region was this right triangle. So now I want to integrate over this right triangle. I'm going to cut up in strips this way. So I'll let you check if you find the equation of this line here, it's equal to v equals negative u plus 1. You can just find, the equation of the line through those 2 points using the slope. Things like that. You can check if you put 1 in place of u, you get 0. And you put 0 in place of u, you get 1. So it goes through there. So we're doing strips this way. So we're integrating with respect to v first. So let's do this. So then our limits will go from 0 to minus u plus 1 on the first one. And then the u goes from 0 to 1, so it'll be 0 to 1 here. So we're doing dv, du. Okay, so let's keep going with this. So we need to integrate with respect to v first. So I'm going to erase this guy here for now. So integrating with respect to v, the first guy would be 324 uv. Integrating this with respect to v would be minus 72 v squared over 2, but 72 over 2 would be 36, would be 36 then. Oops. 36 v squared, and then be 66 v, then evaluate it at 0 and 1 minus u, then du. Okay. So we're going to put the 1 minus u, in place of v here, here, and here. So let's do that. So doing that, so again, putting the 1 minus u in place of v here, here, and here, we get this. Now I'm going to say let say w equal 1 minus u. So then solving for u, because I need to make a substitution for u over here, I'd have then u, bring it over here, bring this over here, equals 1 minus w, and dw, or here, dw, du would be minus 1. Okay. I would then say that dw equals minus du, or minus dw equals du. So let's make those substitutions now over here. So making substitutions again, 1 minus u becomes w, so making those substitutions in u is 1 minus w, we get this. Now w of 1 is going to be 0, and w of 0 is going to be 1. Okay, and let's multiply this in also. So let's do that. I'm going to turn these around, and that will introduce a minus sign. I'll get rid of this minus sign here, and I'm going to multiply this stuff in here. Okay, so multiplying stuff out, you'll get 324w minus 324w squared minus 36w squared plus 66. Combining the w squared terms, you'll get 360. Combining the w terms, you'll get 390. Okay, so let's now integrate this. So integrating this, I'll get a 390 w squared over 2 minus 360 w cubed over 3, evaluate it at 0 and 1, and that's then 195 w squared minus 120 w cubed, evaluated at 0 and 1, so it'll be 195 minus 120, and that becomes 75. So 75 is our answer. So that's the flux over the original triangle of that vector field. Okay, so we're done.